Good morning, everyone. Today we are going to discuss the topic Basics of Security in the subject Information System Security for 6th Sem Section A students of Computer Science, Women Engineering College, Ajmer, and this video is presented by Megha Garg. So let us go to the basics of security. So what is security? Security is the collection of tools which are designed to protect data. Network security is to measures to protect the data during the transmission. What are the security services? Authentication, that means whatever information is going to be delivered to some person, that person must be authenticated to receive it, and it is coming from some authenticated source. So assurance that the communicating entity is the one claimed. Access control is prevention of the unauthorized use of resource. Means if A, B and C are allowed to enter a room and D tries to enter the room, then D should not be allowed because he does not have the access control. Data confidentiality, if the data is to be transported from A to B, then it should not be available to some C outside of A and B. That is the protection of data from unauthorized disclosure. Data integrity, whatever data is sent must be received in the same form without any change. So that is assurance that any data received is as sent by the authorized entity. Non-repudiation, protection against denial by one of the parties in a communication. Non-repudiation means suppose some party A sends a message to party B and later on the same party A denies that I haven't sent any letter or any message to B. Then B can claim that A has sent by the means of its signature, digital signature and so on. Now what is security attack? Any action that compromises the security of information owned by an organization. The classification of security attacks is, it is of two types, passive attack and active attack. Passive attack do not affect system resources. Two types of passive attacks are there. First is the release of message contents, in which the message contents are read by someone else. Traffic analysis, in which they analyze how many packets are, let's say, sent from A to B. And then we have passive attacks are very difficult to detect. Message transmission apparently normal. No alteration of the data. So since the data is not altered, that is why it is difficult to detect. And there is emphasis on prevention rather than detection by means of encryption. Okay, next is the active attack. Active attack try to alter the system resources or affect their operation. They modify data or create false data. And its categories are fabrication, replay, modification of message and denial of service. Difficult to prevent, and the goal is to detect and recover. What is interruption? Here this ball is sending message to this, and in between it is interrupted by something. Interception, this is sending message to this, and in between someone else is also putting an ear and reading these messages. Modification, the message is sent from this, meant for this ball, but in between it goes here, and this modifies the message and sends the modified message to this one. So not the original message is sent to this. Here it starts fabrication. So instead of this, it starts creating its own message and sends to this. This is the fabrication. Now cryptography is the art of secret writing, the art of mangling information into apparent unintelligibility in a manner allowing a secret method of unmangling. So what is encryption? Conversion from plain text to ciphertext, and from ciphertext to plain text back is known as decryption. Basic cryptography model, we have plain text and an encryption key, encryption algorithm which gives you ciphertext, and decryption algorithm and decryption key gives you plain text. In between we have a interceptor. So encryption क्या है? Encryption is the process of transforming information using an algorithm to make it readable and readable to anyone except the one who is having the key. And the reverse process is converting it into plain text, again is known as the decryption process. Now, so what does encryption do? It transforms it into a representation that is no longer understandable. And what is a crypto system? A combination of encryption and decryption methods. Clear text or plain text, which is the information before encryption. Ciphertext, information in encrypting form. One-way cipher, encryption systems that cannot be easily reversed, used for password. Decryption is the process used for decryption. So cryptography is the study of methods to encrypt text. Cryptanalysis is the study of how to decode an encrypted text. Substitution cipher क्या होता है? In substitution cipher, each letter is substituted with a different letter. Caesar's method, replace every letter with +3. So A is replaced by +3, which is D, A. In between we have B, C, D. So +3. So B +3. C, D, E. So D is replaced by E. So +3. Everyone is replaced by +3. This is known as Caesar's method. Other substitution ciphers assign random substitutions so that they are a bit harder to crack. The sender uses the encryption to encrypt the message. The sender transmits the message to the receiver. The receiver decodes the message. How does the receiver decode the message? The sender needs to send the key to the receiver. How can this be done surely so that no one else can decode the message? To secure this, the buyer's machine must encrypt the data before it sends it over the internet to the web server. So what are the algorithms we have? Encryption key is a very large number. Length of key determines how secure the data is, like it's typically between 40 to 128 bits key. Symmetric DES algorithm is there. Asymmetric RSA algorithm is there. So symmetric DES algorithm, which we already saw in the last term, basically uses 64-bit plain text, 56-bit key, and returns a 64-bit ciphertext. And it is a blockchain algorithm. Okay, so this is again the DES algorithm which we studied yesterday. This we saw yesterday. Okay, the symmetric key cryptography principle says that the strength mostly depends on the key length. So here we given the encryption process and decryption process in the symmetric key. So we pad the message in multiples of 8. Add an initialization vector to the front of message. Use chaining to combine the results of the previous block and encrypt each block sequentially. Then in decryption, we decrypt each block sequentially. Use chaining to undo the results of the previous block chaining from the current block. Remove any initialization vector and remove any padded bytes at the end of the front. What is asymmetric encryption or public key encryption? Public key is available to anyone wishing to communicate securely with the key's owner. Private key is available only to the owner. Both keys are able to decrypt and encrypt each other's messages. It is computationally feasible to deduce the private key from the public key. Anyone who has the public key can encrypt information but cannot decrypt it. So an example is given. Denote by raising to 29 power mod 91. 32 power 5 is equals to 2 mod 91. 2 की power 29 is equals to 32 mod 91. In public key encryption, encryption is easy when E is known. Decryption is hard when D is not known. Decryption is easy when D is known. And the most famous algorithm is the RSA algorithm. Alice wants to send messages, encrypted messages. So what it does is it chooses two prime numbers p and q. It computes n is equals to pq and z is equals to p minus 1 into q minus 1. She chooses the number e such that e is a relative prime to z. She finds the number d such that ed minus 1 is divisible by z. She publicizes the pair NE as her public key. She keeps ND secret and destroys PQ and Z. Now Bob wants to send a message to Alice. He looks up her public key NE in a directory. The encrypted message is y is equals to ex is equals to x to the power e mod n. Bob sends y to Alice. To decrypt the message y is equals to x की पावर e mod n, Alice ने क्या किया? Alice received the message from Bob. Alice computes y की power d mod n and claims that dy is equals to x. So this is very simple about RSA. Symmetric key cryptography is at least 100 times faster than RSA. So this was RSA. An example is given. Authentication. Okay, next we'll take the next part in the next lecture. By today it's over with RSA. Thank you.